Welcome to the Greenline product overview. My name is Dana Petroff and I'm with Infinite Green Data Services. I've been with Infinite Green Data Services for 2 years now, but have been working with InContext platform for a little bit longer than that, 4 years, and before that was an owner and operator of call centers for 15 years. And what we have come to find with InContext platform is the best platform out there, but it is challenging, just like all the rest of any system, to get data out in an effective manner and in a way that suits your organization. So what we've done here is productize this code in order to do an end-to-end data warehouse on your behalf. So that is what this Greenline is. And what specifically within that model we're looking at here is that we're capturing the data from InContact, and then on the way in we're transforming it into a data warehouse, into data tables for you so you can save it, and then we're visualizing that for you from a data mart perspective. We're building the data mart, and then we're visualizing that data mart within ClickView. Now that's right out of the box. If you have Tableau, if you have Burst, if you have Domo, we can build that. We can build this onto those platforms as well. But out of the box, we have ClickView ready and set for you. If you don't have a license to ClickView, we can help facilitate that. Or we can help facilitate any of the other platforms of your choosing. Typically, an organization will have one or the other, so we can help with either one of those. Out of the box, again, out of the box, we have ClickView visualizations built. And what we have from a source system perspective InContact out of the box is normalization of that data. So we're capturing and we're transforming, we're putting it into a normalized format so it can be integrated with other systems, the data from those systems. And then we're going to store that data into a data model, into a data warehouse that's pre-built. It's already built for you, it's already going to be filled up as we as we install and press the button. So from that day forward, you will have all of your data as long as you choose, as long as your data strategy tells you to keep the data. And what that is going to do, hopefully, is accelerate your operation. So the easy stuff now is in your data warehouse, and all you need to do is write some SQL statements or use the visualizations that we've provided, or hire on somebody else to make different visualizations to accelerate your operation. So you're no longer looking at, how do I get the AHT for this week, or what was the call demand last week? Those simple answers are easily handled by Greenline, and it provides you access to those data elements, and provides you a visualization layer that's pretty intuitive, and is the result of 18 years of working in the business. A typical installation for the InContact platform will take 2 business days. That's a lot of work consolidated down into a very simple press the button. So we're going to test the accuracy. We're going to go through test scripts, and we're going to make sure that the thing works for you as intended. But needless to say, it's a 2-day process, so we can get this up and running. Now, our case study actually was not on the InContact platform, but was from a different contact management platform, one that is much more difficult to use than InContact. However, we were able to install and make it very effective for this team. And what the initial state here is pretty much wherever we go and look, is the initial state of everyone on the team is 20% of their day is trying to drive out insights and analytics from data. But the other 80% of their day is typically focused around modeling data and putting it into formats that fit with other formatted data. So the majority of the time is spent in Excel spreadsheets, doing pivot tables, trying to find the right mix and the right match to integrate data across systems. That's a lot of time, and that's what we found at Intuit as well within this case study. Our implementation here saved them a lot of time. The ROI was 50%, but that was based on only one person with 2 hours a day. We didn't have time we didn't have the runway to be able to assess just as how far that reached into their organization. So my guess is that there were at least 4 other people doing 2 hours a day of ETLing, of data structuring, because these ad hoc, they didn't really have an ad hoc process. It was just, hey, can you get this by this? Can you get this by that week, by that vendor? These sort of things. And this, as we go through the demo within ClickView, you will see how quickly people are able to move throughout the tool to get the answers they need. So we wanted to normalize data between forecasted and actual data. There's a constant stream of requests coming through with different dimensions, but there was no scalability for these folks. They had to grow every analysis, every report from scratch, and that took quite a bit of time and made up that 80%. Post-implementation, however, we flipped it so that we almost automated the entire thing, where only 20% of the time was moving data around and structuring data, and 80% now could be focused upon what happened and what's the insight here and what do we need to do going forward, who do we need to call, these sort of things to get our operation in alignment with our customer. The time that it saves, from a benefit perspective, was incalculable. I mean, there are 64 people on the platform looking and using ClickView now with this data. Not sure exactly how many different people, stakeholders used it before, but now it's a one-stop shop. You can go there and get almost every question, at least operationally, that you need to know about forecasted versus actuals. Accuracy, going through the exercise, we also found a few errors, a few discrepancies, and a few things that people weren't clear on. So by going through this, implementing Greenline, we increased the accuracy here as well. The faster insight, again, going back to the time, the dimensionality here, I can't underscore enough how important that was to this exercise, to the study. And you'll see, I'm going to jump in now to the other piece here where we show the demo. But you can see the level of dimensionality that was required here. Down the left side of the screen, as you can see, there's vendors listed here. There's business categories here. There are product categories here. There are a different iteration of product category. There's language. There's country, and then our favorite is time. So a big part of this is time dimensions. Here, let me start from the beginning. We try to set up a nice looking, easy to navigate front end where we click, whatever based on that business data, right? Where we want to start. This happens to be defaulted to the 2nd of April. Now we can clear this all out very simply by clicking on the clear button, and then let me just get to a different view here. Now we can start clicking around and viewing exactly what we need to see. So let's look at March. This is the full month of March. Now if we go over to data by interval, we're looking at the full month of March by day, by 30-minute interval. And by the way, green line brings that down to 15-minute intervals. And we can see now the efficacy, how well we're forecasting. We can do that overall by looking at a total look here. If I can, yeah, so 46% variance where the offered came in. The forecast, was at 122,000 calls, and the actuals was 178,000 calls. Now that's quite a steep difference, but if you think about March and tax time for these folks, quite a bit volatile in that time frame. There's also these high level abandonment rate. We factored in goals here, green representing the goals, yellow representing warning areas, and then red are bad, of course. We have totals depending on what we're going to choose here for the month of March. If there are, where did they go? Let's say the week of 3/9 only. So now we're looking at 3/9 within the month of March. Now these calls versus actuals. So the variance on this week was not that large. The abandonment rate was a little bit under goal. The HT was a little bit over goal, but they did well on their SLA. So that's data by interval. We can do the same thing again. Remember we're on March, the week of 3/9. Here's the week of 3/9, and then we go to the 10th, 11th, 12th, 14th. So you can see here's the 11% that we spoke about before. There's variance intraday, right, or interday, but the end result is 11% variance there. We also have the ability to range find. So instead of just the 3/9, we have the ability to stretch. Let's go 2/1 to 3/1 and see how February worked out. Okay, well, 42% difference there. Right, so we can have a few different range finders, range looks to be able to be incorporated within your customized app. But out of the box, this is functionality that sits here. For this one to work for your organization, we just need to have the same data components as these other forecasted volumes. So forecasted demand here, we need forecasted AHT, we need forecasted service level, and then hopefully we can get required hours. So how many people are required to be on the phone versus how many people are scheduled to be on the phone. There's a difference there, of course. And then if you have goals for these metrics as well. So moving on to some graphical interpretations of this data. We're looking here at kind of a 4 or 5 box view. Abandonment rate, the dotted line represents a forecast. So both of these, all of these have forecasts, and the solid line represents what actually happened. So you can see the abandonment rate in the later hours, 6 to 10 p.m. is quite a bit higher than goal. That's obviously because the staff is less, but it also could reflect a call volume spike that wasn't expected. Now if we go over here to look at that call volume that's coming in, there is a gap between what was forecasted and what actually happened. but it's slight. It's not as large as what is driving this. So what that tells me is that it's a bigger staffing issue than it is a volume issue. Again, here's service level that goes pretty much in lockstep, inverse to goal compared to abandonment rate. But basically, what we're saying is it's not where it should be. Average speed of answer as well. You can see that's way below goal here for the majority of the day, which is good. But then at the bookends, again, we're looking at some challenges there. And then for those of you who like to look at HT and where that forecast is versus where your agents are coming in, as a component of cost in some respects, that there it is for you. And that is actually these are intervals by date. Interval components here. So if we look at just one particular day, the 10th, which we don't have actuals for. I think we have actuals for the 6th though. Yep. So we're looking at one day, and we're looking between 4 a.m. and 9 p.m. and what occurred. Well, call volumes were over forecast the entire day. We dipped below the goal on abandonment rate, which is good, but again on the bookends we had a little bit of trouble here. Service level looked okay most of the day, and average speed of answer was very volatile. So what I'm trying to illustrate here is if we clear this out and we're then looking at questions like, well, what is it? What's it for the week? What's it for the month? These sort of questions are typically very difficult for spreadsheets to handle and graphically represent. But here it's as easy as going back to the date field, going back to a date and picking 3/9, and there you have it. This is the week of 3/9 in aggregate. So in aggregate, you have a solid line here, which is over forecast from the dotted line. So you're getting call volume much higher than demand, or much higher than forecast. Your abandonment rate, right? So we can see all this within 2 clicks, right? Then we also have presented this at a date level as well. So very easily we can see again for this week of 3/9 how over forecast it is. Oop, I clicked. Now it's going to change on me. But this represents the overage and performance at a high level. Now getting into staffing, again, the required versus scheduled, like what's actually scheduled and what's actually required. This is a little bit of the art and science combined from a forecasting perspective. So what you'll see here in the line represents the required hours. So during this day, or sorry, this week, we're still on 3/9, the week of 3/9. This is what is required from a people perspective. But as you can see with the bar graph, this is actually what's going to be scheduled. So as a result of this is, these results are a direct result of the calls coming in. This forecast here results in these calls coming in and being serviced in the way that they needed to be. So service level looked pretty good, abandonment rate looked pretty good, average speed of answer looked pretty good. So this actually worked. Now one can argue the fact that they paid a premium for those results because of the difference between having let's call it 1,180 people needed, or let's just call it 1,200 people needed on the phone, but they paid 1,600 to be there on the ready. So one could argue that it wasn't efficient, but one also could argue that the folks were serviced appropriately. So there's, if you can pay for that and people are serviced appropriately, very good performance. Okay, lastly, we have a different view based on vendors. So one of the challenges as well was contractually, how do we ensure that each of our vendors gets the same amount contractually than the other vendor. There was somewhat of that type of competition within the model that existed, which was good, and this was always a challenge to quickly be able to understand how many calls that vendor 1 received that day versus vendor 2, and vice versa. And then also, so how much did we send to them, but how did they effectively perform? So for one example, from an average handle time perspective, who had a good forecast and who had a bad forecasted day. So this represents, the actuals. Some of these 40-minute AHT for this half hour, where they were actually scheduled for a 15-minute handle time. These three right here are outliers, right? They happen to be third-party vendors. The blue ones, these are the next closest. They're, again, the 30-minute and 12-minute. So they're forecasted to come in on this line, but as further right as you go, that's not good. The 15-minute is right here, the 12. So a lot of the results were forecasted and actualized within here, but there are some intervals that had outliers. So it's a quick way to look and see where your outliers are and where you need to dig down further. Same with this slide to the left on service level. The red dots represent what's forecasted as far as a service level goes across all the vendors, and then the diamonds represent where they actually came in. So this particular interval that we're looking at there was a very large gap between 50% SLA and 80% SLA. So again, this is a really quick way. I clicked, so it's going to do something like that. If I click out, let's see if I get back. Nope. That was, nope. Come on now. Okay, well, let's go back here. Go to the week. We'll stay on 3.9. Kind of like that week. And here we are again. The last one from a partner perspective, just a few other ideas around visualizing the data. This is held calls versus handled calls. So if you have a third-party vendor or a few third-party vendors, you can understand where they are holding on to the, putting your customer on hold. This ratio has the number of calls versus the number. 300 calls were put on hold out of 1,400. What's that correct ratio? Now this internal team within this company, they have a lot more information, perceived information at very least, but real information. So they're probably putting people on hold and going and getting that question answered. Okay, well that is pretty much it for out-of-the-box green line visualizations. Thank you very much for your time, and I hope to hear from you. Thank you very much.